So they said a flask contains 300 centimeter cube of dilute acid, right? So we're doing 7.2. So they said a flask contains 300 centimeter cube of dilute sodium hydroxide and a concentration of that. So we're given information about sodium hydroxide, right? So NaOH. So we're given information about it. We're given that it's 300 centimeter cube, meaning that it's 0.3 decimeter cube, right? I'm just converting it. So, and then let me see a concentration of 0. So that's the okay. So this is the volume, and then the concentration is what is 0.167 moles per decimeter cube, right? All right. So let me see. What did I do? This is just decimeter cube. So moles per decimeter cube. So from here, if we want, we can get the number of moles. Let's just calculate the number of moles. Let's calculate it because we're obviously going to need it. And then that's actually what they're asking, 7.2.1, calculate the number of moles of sodium hydroxide in a flask. So C is equals to N over V. So then 0.167 is equals to N over 0.3. So N will therefore be equals to 0.0501. All right, great. We found the number of moles. We are going to need it for the next questions. So where is that? So let's go to the next one. So now they said ethanoic acid of volume 500 centimeter cube. So now we have got ethanoic acid. I believe, okay, fine, ethanoic acid. So let me just write it in condensed structural formula. So this is going to be CH3COOH. Yeah, it has to be this. I think it's minus. I think so. Matter of fact, I actually don't think it's minus. Let's just say I got it right. I'm going to check the formula. Let me see. Is it written in this? Let me just see if they gave us the balance equation. Yeah, they did, and it is indeed correct. All right, so now we have got information of this as well. So the information here is 500 centimeter cube, which in volume, in decimeter cube is going to be 0.5 decimeter cube. So then an unknown concentration, so we don't have the concentration. All right, no problem. So now we don't have the concentration, so C is just X. So they said it is added because usually one thing you must know is that an acid has got its own concentration, not like the acid on its own. It's inside a container, so therefore the container has its own concentration. So they like adding it on something, right? So usually the volume adds up, right? So this will be in a container that has its own concentration. This will be in a container that has its own concentration. Then they will add it up, right? So some past papers will tell you that assume the volumes are additive, right? So whenever they ask you about something in excess, or whenever you're thinking about something that is in excess, always remember that the excess one is the combination, right? Whenever they react the acid and the base, the volumes would have add up, right? So the excess will remain on where there is a total. So I'm going to explain this again just now. So let me see. Okay, fine. So they said it's added to the flask to give it a volume of 800, right? So remember, this one is 0.5, this one is 0.3, right? So they're added together in a bigger one. So they're added together so that they can react. So now we're going to have NaOH reacting with ethanoic acid, right? So together the volumes is going to be 0.8 decimeter cube. So 800 centimeter cube, which is 0.8 decimeter cube, right? So 0.8 decimeter cube. So that's how it is. So when these two react, there is going to be an excess. So that's how this topic is, right? Usually when these two react, they won't like neutralize each other. One is going to be more than the other. So one is going to be in excess. And when you're calculating the number of moles of the ones that is in excess, maybe if you want to find out what is, let's just say you want to calculate the concentration of the one that is in excess. So notice these two will react, and then maybe the acid will be left, maybe the base is the one that is going to be left. So if you want to calculate the concentration of the one that is in excess, what you'll do is that we'll say, so let's just say we have the number of moles of the ones that is in excess, right? So C is going to be N over V, but the volume is always the total when they're added together, right? So then the volume would be that 0.8. So I hope you get it. So now let's see. So now they say this added to give the volume of that, right? Now they said it is found that the pH of the mixer is 11.4. So whenever they give you the pH is always formed because of the excess, right? So the pH, right? So notice the pH is 11.4, so the pH is above 7, meaning that it's a base. So we know that the base is the one that is in excess, right? If the pH was like something like maybe 3, we would know that the acid would be the one that is in excess. So far we know that the base is the one that is in excess. So they gave us the pH, right? So the pH is 11.4. So because the base is the one that is in excess, we need to get the concentration of the base that is in excess, right? So when we get the concentration of the base that is in excess, we'll also be able to get the number of moles of the base that is in excess. So that's always what you do with pH. So we know that the base is the one that is going to be in excess. So you'll always need to create this equation. So because the base is in excess, because we have NaOH that is in excess, then this will go under hydrolysis, right? So with water, then this is going to be, so whenever we do this equation, we know that this is a base, so therefore it's a proton acceptor. So it will take H from H2O, right? So it will take H from H2O, but when it takes H, it's going to break down. So this OH will combine with that H and it becomes H2O. So we're going to be left with Na plus H2O plus here one proton was taken. So here is going to remain OH, right? So the base always produces OH. So now let's go further. Let me just see something. So now we're given the pH, right? But whenever you're given a pH and you see that it is a base, because whenever the pH is above 7, we know that it's the base that is going to react, right? So we cannot use the pH, right? Because it's the base that is in excess. So we have to use the POH, right? So this is what you'll do. Or even if you don't use POH, there is another formula. So another formula that we can use is the concentration of H3O times the concentration of hydroxyl ions, right? This thing is always equals to 1 times 10 to the power of negative 14, right? So far, we can get the concentration of H here, right? So pH is 11.4, meaning that we know that the formula is pH is equals to minus log concentration of, so some students actually put log 10. So in this case, this is going to be useful. So it's going to be the concentration of H3O, right? So every time we talk about pH, it's strictly the concentration of H3O, strictly, right?
Just before I continue, if you want to be treated, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
Watch the video that is found at the end of this video in order to know the prices and the updated contact details just in case this was changed. Alright, let's proceed. So that's what we have. So far we already know pH. pH is 11.4. So now we're going to find, we have to calculate for the concentration of H3O, right? Hydrogen ions. So now this, when you have to put it in exponential form, notice, fine, let me just write this first. Let's just write this. So I'm going to talk about that. So far we have this. So we're solving for hydrogen ions, right? So we want to find the concentration. So every time you want to convert it back into exponential graph, the exponent is always the subject to the formula, the base is always the base. So this is called log H3O base 10. So if I do this, for instance, this is going to be called log 5 base 2. So notice this base is already the base, right? So it's going to be 10 as the base. And then the subject to the formula is always the exponent. So 10 to the power of 11.4. And then we'll be able to find the concentration. So if you want, we can just put it here. So still the same. So concentration of H3O. So we'll be able to find it, right? So this is 11.4. So let's find it. Matter of fact, at this point, I'm not going to find it. I can just take this and substitute it because we're interested in concentration of OH. So now we have this answer. So we have 10 to the power of 11.4, and then we've got concentration of OH, which is what we're trying to find. This is equals to 1 times 10 to the power of negative 14. So now we can divide both sides. So for us to find the concentration of OH, we'll just divide them, right? So we're going to say 1 times 10 to the power of negative 14 all over 10 to the power of 11.4. So let's figure out the concentration of OH. So always remember, if the pH is less than 7, we know that the acid was the one that was in excess. So we would have created this equation, but for the acid, right? That's what we would have done. And then we would have used the concentration of H3O. But because it's a base, because the pH was above 7, we know that the base was the one that was in excess. So the base is the one that is going to undergo hydrolysis. So in this thing, the base was more than the acid. So they reacted, but the base was left. So there's an extra, right? So the base was in excess. So the one that is in excess will react with water according to this equation. So that's always what happens. Whenever we're given pH, we know that there is something that is in excess, and we always use this equation. So you'll also always use this equation to find the concentration, right? So that's how it is. So now let's just calculate this part. And let's just look at something a bit. I just noticed something over here. This is negative, so my advice is to take this negative this side first, right? So if we did that, then this would have actually been negative, right? So it's 10 to the power of negative that. So let's picture that as negative. So yep, let's just be careful of that part. So yeah, I literally left it out. Alright, so now if we have this, our answer should be something like, so answer should be what? It should be 2.51, right? So 2.51 times 10 to the power of, let me see, so times 10 to the power of 3 minus 3. So that should be our concentration. So now I found the concentration of the one that is in excess, right? So this concentration is what is in excess in this stuff. So I want you to be aware that this concentration is the concentration of OH, right? So when we have the concentration of OH, we also have the concentration of NaOH, that is in excess, right? So when we have the concentration of OH, we have this concentration as well. So the ratio is 1:1, right? Meaning that that's the same. But if it was 2:1, so if this was 2, let's just pretend that it was 2 and this was 1, you would have said 2:1, right? So meaning that we have the answer of this, which is 2,51 times 10 to the power of negative 3. And you are trying to find the concentration of this one. So then you just cross multiply. So in this case, it would have been 1 times x, which is just x, and then this would have just been times 2. So that's what you do. So you just cross multiply. What if it was instead 1:2? Let's just say this was 2. Then you would have said 1:2. So when you cross multiply, this would have been 2x. And then this one, when you cross multiply, is just 2,51 times 10 to the power of minus 3. And then you divide both sides by 2, and then you end up getting x. So that's how it is. So far we now have the concentration of NaOH, right? So let me remove this equation. So we have found the concentration in excess. So now that we have found the concentration in excess, we are going to find the number of moles of the one that was in excess, right? So we know that C is equals to N over V. So concentration is that 2.51 times 10 to the power of minus 3. So this is equals to N over V. We're looking for the number of moles of the one that is in excess, right? Remember, the one that is in excess is always in the combined container, right? So then this is going to be 0.8. So that's the volume, right? Which was the 800 centimeter cube. So now the centimeter cube 0.8. So now we just have to multiply this stuff. So this is what we're going to have when we multiply them. So the number of moles of the one that is in excess is 0.002, right? So here I'm kind of rounding off. I'm just showing you the figure. So the real figure is somewhere like 0.008, right? So let me just leave it like this for now. Okay, so I don't think it will really affect, but yeah. So this is the number of moles of the one that is in excess, right? So they're asking us to calculate the initial concentration, right? So for us to find the initial concentration, notice that this is the limiting reagent, meaning that it will all finish in the reaction, right? So meaning that if we find the number of, so rather, we have to first find, so this is going to finish, like all of it is going to finish, right? So what I have to do is to find the number of moles of NaOH that reacted, right? So if I find the number of moles of NaOH that reacted, I'll be able to relate it using the ratio. Alright, so if I find the number of moles of this that reacted, I'll be able to use the ratio to find the number of moles of this that reacted. Then in turn, we'll be able to find the concentration because the whole thing reacted, right? So let's find the number of moles that reacted. So far we know the number of moles of the one that is in excess. So now we have to find, this is going to be the total number of moles because this was in excess. Since this finished first, we know that this is in excess. So if we find the number of moles of this, and that's actually what they asked us in the previous question, we actually have it. We have the number of moles of the one that was in total. And now we have the number of moles of the one that is in excess. So therefore we can get the number of moles of the one that reacted, which is going to be, so number of moles of the one that reacted. So let me just do this, number of moles of NaOH that reacted, right? That reacted. Yeah, okay. So that reacted is equals to the number of moles in excess. So number of moles in excess, let me just do this. So you can just write number of moles in excess minus, number of moles that of the original minus the number of moles in excess. So I'm just writing it in short. So then this is going to be, what is it going to be? It's going to be 0.0501 minus 0.002, right? So I don't think it will really affect, but let me just do this. So now we'll have the number of moles. So let's calculate it. So that should be okay, fine, what did I just do? So that should be 0.04892. I'm just choosing not to round off. So this is what we have. So now let me get, so now we have the number of moles of the one that reacted, right? So let's look at the equation from the question. Okay, so let's look at the equation from the question. So the equation from the question we have, notice that the ratio is 1:1, right? The ratio of these two is 1:1. So meaning that the number of moles here that reacted is the same as the number of moles here that reacted, right? So now we have the number of moles, so we can easily find the concentration. We're literally done, right? So now we have the volume with the number of moles. So we know that C is equals to N over V. So now we can find the initial concentration. So C is equals to N, which is 0.04892 over the volume, the initial volume, which was 0.5, right? So this was the volume. So there we have it. So I don't think I even have to get this answer. I think you get it. So that's what we have. So let me just calculate. Yeah, so somewhere there should be somewhere around 0.09. Yeah, 0.09. So 96184. So eventually we'll just say C is equals to 9.62 times 10 to the power of 2. Yeah, 10 to the power of negative 2. Yeah, so I hope you get it. So that's the concentration. We have found it. So I hope you get it.